Hello everyone, and welcome to Precalculus, section 2.6 on rational functions. A rational function is a function of the form f of x is equal to n of x, n standing for numerator, over d of x, d standing for denominator. And both the numerator and the denominator are their own polynomials, where the denominator is not equal to 0. So the way to remember that a rational function is really just a fractional function is it has the word ratio in it, which always means some kind of fraction. All right, so when the numerator and the denominator are linear, x to the first power, then the graph will always be a hyperbola, although it may be shifted left, right, up, down. Today, we're going to learn how to graph rational functions where the numerator and the denominator are not linear. So you were supposed to do linear ones in Algebra 2. I will do one just to make sure we've got it, but then we're going to move on to more complicated ones. First step, by the way, if you just follow these 8 steps, literally write them in your appendix if you're in college prep, and just follow these 8 steps every time, this is usually people's most successful section of the chapter. Because it's just about paying attention to the details. All right, so step 1, always simplify the function if possible. Unfortunately, you might only have to simplify one function in every 5, so it's easy to forget that step because you don't always have to do it. But you always have to do the rest of the steps. Find the X intercept by letting y be equal to 0. And then you'll have some kind of a number, comma 0. Find the y-intercept by letting x be equal to 0. And that'll give you 0, comma, a number. We're going to find the vertical asymptote by letting d of x, the denominator, be equal to 0. And then there's going to be a horizontal asymptote. There are 3 different things that could happen with the horizontal asymptote. If the degree of the numerator is the same as the degree of the denominator, so let's say you had 3x squared plus 4x over 2x squared minus 1. They both have a degree of 2. So in that case, the horizontal asymptote is going to be y is equal to a over b. In this case, y is equal to 3 over 2. Remember that when y is equal to a number is graphed, it's always a horizontal line. So this would be the horizontal asymptote. I guess I should say that for those of you that don't remember, an asymptote is like a guideline that the graph follows in the end. The horizontal asymptote will always show you the end behavior of the graph. Now, sometimes the degree of the numerator is less than the degree of the denominator. Maybe something like this. If that's the case, the horizontal asymptote is always going to be y is equal to 0. And if you're the type of kid that doesn't want to just do something, you want to understand why, think of this as being 0x squared. And then the same rule applies. You can compare there 2 of them. So it's 0 over 2, which is 0. But you could just memorize it. Whenever the degree of the numerator is less than that of the denominator, it's just always going to be 0. The last one is a little trickier. If the degree of the numerator is higher than the degree of the denominator, x cubed plus 2x over x squared minus 1, then there is not a horizontal asymptote, but rather an oblique, also referred to as a slant asymptote, for which we use long division to find. So we'll get there in a few minutes. Draw what you know so far. You might have to make a table and plot a few more points, and then you should be able to complete the graph. So the entire rest of this lesson is just graphs. There's no other notes. So we're just gonna go one at a time. If you think you can do some of these, I would love for you to just fast forward to all the pictures, and that would be totally fine with me. If you were in class, that's what you would be doing. I would break you off into groups now, and you would be working together. All right, so here's our parent graph from Algebra 2. This is a hyperbola. So we find the x-intercept by letting y be equal to 0. But then when I go to clear the fractions, multiplying both sides by x, I get 0 is equal to 1, which of course is not true. So there is no x-intercept. Likewise, for the y-intercept, I let x be equal to 0, but you can't do that because you can't divide by 0. So there's no y-intercept. We find the vertical asymptote by letting the denominator be equal to 0. So that was easy. Didn't even have to solve anything. Vertical asymptote. And we find the horizontal asymptote if the degree of the numerator, well, that's definitely no x's, and then x to the first, is lower than the degree of the denominator, then the horizontal asymptote is just y is equal to 0. We'll do domain at the end. So let's draw our asymptotes. Here is the line x is equal to 0. Here is the line y is equal to 0. Normally we have a couple intercepts that we can plot, but in this case we do not. So we're just going to have to do the last step, which is to make a table and plot some points. So I'm going to make this table. Remember that y is equal to 1 over x. So when x is 1, y is 1. When x is 2, y is 1/2. I can hopefully see the pattern pretty quickly. 1, 1, 1/2, 1/3. And when x is -1, it's -1, -2, -1/2. So -1, -1, -2, -1/2. And this is where, if you understand what the shape is, you would never have had to plot this many points. You could just use the asymptotes as guides and just plot 1 point. This is what a parabola or a hyperbola looks like. Remember that domain always happens in 2 instances, if there's a radical or if there's a denominator. So since there's a denominator, you have to ask yourself, what can't x be? X is not equal to 0. It will always be related to the vertical asymptote. The vertical asymptote literally tells you what the domain is. So the vertical asymptote is equal to, because that's the equation of that vertical line. The domain is saying, what can't x be? X can't be 0. So there's the parent graph. We'll keep going. X intercept. So just so you know, I usually fill these in advance. The x intercept is going to be something, comma 0. The y intercept is going to be 0, comma something. The vertical asymptote is going to be a vertical line, so x is equal to a number. And the horizontal asymptote is going to be y is equal to a number. And then the domain, I'm going to put it back in blue again. And if I can get my pen to work. There we go. Is going to be x is not equal to. So remember, these two are always going to be related. So if you want to write those few things down on your appendix, every single time that's what you're going to do. So I'll color code them to make it easier. X intercept, let the y be equal to 0. I clear the fraction. And I get 0 is equal to 2x squared. Now, you don't really have to divide by 2 and then square root. I'm sure you can see right away that x is equal to 0. Y intercept, plug in 0 for x. So y is equal to 2 times 0 squared minus 1 is 0 over negative 1. Notice not 0 over 0. You can't have a 0 in denominator. So it's equal to 0. Vertical asymptote is whatever makes the denominator equal to 0. So you're going to always set the denominator equal to 0. I'm going to factor, set equal to 0, and factor is how you always solve. Now I could have, since there was no x term, I could have added the 1 to both sides. That's also an acceptable thing to do. If you are going to remember your plus and minus, if you're going to forget that plus or minus, you're better off factoring. Horizontal asymptote is found by looking at the equation. And in our case, the powers are the same. So since the powers are the same, I'm going to make the y horizontal asymptote 2 over 1, which is just y is equal to 2. What can't x be? Well, since there's a vertical asymptote at 1 and negative 1, x can't be plus or minus 1. On your quizzes and tests, these are each going to be worth a point, and then the graph will be worth 2 points. So you're getting a lot of points just for being able to fill in this chart. Okay, let's do our asymptotes first. So x is equal to 1, vertical line, still keeping it color-coded, negative 1. Horizontal asymptote, y is equal to 2. And now we have a couple, actually just 1 point that we can plot, which is 0. So when you have this H formation, the graph can do a couple different things, but they do tend to have patterns. So sometimes they look like this, or they're opposite. Or sometimes they do this, they cross through. And this one confuses people because they say, oh, I thought it couldn't cross the horizontal asymptote. I thought that was a guide. The horizontal asymptotes only tell you end behavior. It's only the vertical asymptotes that something can't cross. So vertical asymptotes will never be crossed. If you cross a vertical asymptote, then you're doing something wrong. But a horizontal asymptote just tells you what's happening in the end. So it could start down and then go up and then go like that. That's another possibility. What you can be sure of is that you'll never have something, if it's an H, in the top and the bottom, because it doesn't pass the vertical line test. So always be keeping that in mind. There's only going to be one thing in each section. So we got to figure out which one this is. So this is where, I don't know if you remember from chapter 1, we spent a lot of time on even and odd functions. This is definitely an even function. No matter what you plug in for x, if I put in a 2, let's say, I get 2 times 4 is 8 over 3. If I put in a 2, it doesn't matter if I put in a negative 2 because it's being squared. It's still squared on the bottom. I'm still going to get 8 over 3. That's what tells you something is an even function. Why is that so important? It's important because now when I go to graph that, 8/3 is the same as 2 and 1/3. So when I go to graph that, 2 and 2 1/3, I know that the other one is going to go over here. Oh, I missed it. which means this one must do this in the middle. So you might not remember your even and odd functions or didn't learn them as well as you should have during chapter 1. If that's the case, you're going to have to plot a lot more points. But this is why, like, everything's going to be connected in math. So things that you learned in chapter 1 are actually going to help you for chapter 2. Everybody got that one? Okay. So if you get one like number 3, it doesn't happen often, but I would convert it to a single fraction. It's very easy to do. You're going to take the 1 and you're going to multiply it on the top and on the bottom by the same denominator as the other one, because that cancels, right? So I'm allowed to do it. And I want to do it because now I'm going to have identical denominators. So this is x minus 2. So x minus 2 plus 3 becomes x plus 1 over x minus 2. This is the function. It means the same thing, but now I can use all my little rules that I taught you. Okay, X intercept is going to be something comma 0. Y intercept is going to be 0 comma something. Vertical asymptote is going to be x is equal to. And then the domain is going to be the same thing, but x is not equal to. And horizontal asymptote is going to be y is equal to. Fill that in first and it'll make your life easier. So now doing them one at a time. How do we find the x-intercept? We let y be 0. Now you don't really need to clear the fractions here. If you have a fraction that's equal to 0, it's because the top is equal to 0. So this means that x is equal to -1. That's what would cause it to be equal to 0. For our y-intercept, we let x be 0. 0 plus 1 over 0 minus 2 is -1/2. For our vertical asymptotes, we let the denominator equal to 0. There's our denominator, equal to 0, and we get x is equal to 2. Which means if there's a vertical asymptote there, vertical asymptote at 2, that means that that's the one number that x is never going to be. This graph is going to go all around it, but it's never actually going to have a single point on that vertical asymptote. And then the horizontal asymptote is y is equal to x plus 1 over x minus 1. I see they have the same power. They're both linear. So I can look at the a and the b, which is 1 over 1. Okay, the way you find a horizontal asymptote is to look at the number before the x, which you can't see, but it's a 1, and just divide them if the two powers are the same. So y is equal to 1. And I'm going to graph my horizontal asymptote. Now I'm going to plot what I know so far. I know the x-intercept is at -1, 0. I know the y-intercept is at 0, -1/2. And I know the asymptotes. Just go ahead and draw it. You don't really have to find more points. This is plenty of points when you have asymptotes. Asymptotes are awesome. Now I do need one good point on the other side. So just pick any number bigger than 2. If you pick something less than 2, you're just going to get one of these points over here. But pick a number bigger than 2. So let's say 3. So 3 plus 1, isn't this easier to use than that 1 plus thing? Over 3 minus 2 is 4 over 1, so 4. So at 3, it's 1, 2, 3, 4, and that's enough. Listen carefully. I only require 1 point on each branch. Okay? My pen does not want to work today. I think it's cold this morning. I know you might not be watching it in the morning, but I'm drawing it in the morning. Okay, so kind of. So here we go. I follow the asymptotes and I go through my 1 point and I call it a day. Okay? All right, let's do another one. X intercept, something comma 0. How do I get the x-intercept? By letting y be equal to 0. 0 is 2x minus 1 over x. What's the only part of a fraction that can make something equal to 0? The numerator. I can prove that easily. 0 is 2x minus 1. So it's always going to be the numerator that causes it to be equal to 0. Add 1 to both sides, divide by 2. That's my x-intercept. Y-intercept is always going to be 0 comma something. So that 0 is the x-coordinate. So I'm going to put a 0 in where I see an x. Ooh, I can't divide by 0. So there is no y-intercept on this graph. If your graph crosses the y-intercept, y-axis, I'm going to mark it wrong. Vertical asymptote is always x is equal to a number, and then domain is always x is not equal to that number. Well, we kind of just discovered it, right, a second ago? So you set the denominator equal to 0. So there's nothing to solve there, it's already done. So the one number that x can't be in this equation is 0. And finally, our horizontal asymptote. Again, we have two identical powers. They're both to the first power. They're both linear. So I can do the coefficient over the coefficient. So y is 2 over 1, which is 2. So I fill in as much as I know. I know that y is equal to 2 is the horizontal asymptote. Now I'm going to draw my vertical asymptote, which is going to be x is equal to 0. Now I'm going to plot my x-intercept. 1/2 0, there's no y-intercept, but that one point is enough for me to graph this entire branch. I follow the asymptote, I go through the point, and then I follow the asymptote. So now I know, I'm pretty confident that the other one's going to go over here, but we do need to plot at least one point to get that branch. So make sure you pick a negative number. If you pick a positive number, you're just going to get something already on your red branch. So let's pick -1. Why make it hard on ourselves? So 2 times -1 minus 1 over -1 is -3 over -1, which is 3. And that makes sense to me. That looks like it's going to be right. So I can go like this. Okay. There we go. Next one. Graph y is equal to x over x squared minus x minus 2. Let's go ahead and fill in all these pieces. So it's going to be something comma 0, 0 comma something, x is equal to a number, y is equal to a number, x is not equal to a number. Filling that in real quick is always helpful. It also kind of serves as a guideline. So how do you find an x-intercept? Let the y be 0. What is the only part of the fraction that matters when you're setting it equal to 0? The numerator. So 0, 0 is your x-intercept. For your y-intercept, you're going to let the x be 0. Now you might think, why even bother to finish? I do have to finish because I have to make sure the denominator doesn't come out to be 0. But it doesn't. So 0 over -2 is 0. Because if it came out to be 0 on the bottom, I'd have to say that there was no y-intercept. My vertical asymptote, I let the denominator be equal to 0. Whenever you have an x squared in equation, set it equal to 0 and factor. And my two intercepts are 2 and -1. Which means those are the two numbers that x can't be equal to. So I'm going to draw an asymptote at 2, and I'm never going to cross it. That's x is never going to be that number, and x is never going to be -1. my horizontal asymptote, since the degree of the numerator is less than the degree of the denominator, I know that it's going to be y is equal to 0. If it helps you, you can think of it as 0x squared and use the same rule we've been applying, 0 over 1. So here's y is equal to 0. And we only know 1 point. Bummer. This is the only point we know. Now this graph isn't even. If I pick an x like 3 and then x is negative 3, it's definitely going to come out to be a different answer. So, and I can see that this is not centered between the two asymptotes. So I'm pretty sure it's probably more likely to look, actually I'll make these dashed. Still didn't make them dashed. So I suspect with that 1 point being there, it's going to do something like that, which means it could do this. I'm not really sure. We're going to plot a few points, but that's my guess. The more you, how do I know that? The more you do of these, the better you'll get at just knowing, anticipating what they're going to look like. But I do have to make a little table. I'm going to pick 1. I think that's going to tell me a lot. If it goes down or if it goes up, that'll help me know something. So when x is 1, I get 1 over 1 squared minus 1 minus 2. So 1 over, so the 1 minus 1 cancels and I get negative 2, so negative 1/2. So it went down. So I feel like it's going to do this. If the other two graphs come out in opposite corners, then I'll know I was right. Now I have to pick something to the right of this to get one of these two sections. So I have to 1, 2, at least 3. So 3 over 3 squared minus 3 minus 2 is 3 over 4. So at 3, it's 3/4. That's enough for me. I'm going to go like that. So I wasn't exactly right, but instead of there, which means, though, now I'm expecting this one to go here. Okay, let's see if we're right. Let's do, we could do negative 3, but I could just do negative 2. I just need to get to the left of that asymptote. So negative 2 will give me negative 2 over negative 2 squared is 4 minus a minus 2, and then minus 2 gives me negative 2 over 4, which is negative 1/2. So at negative 2, it's negative 1/2, which is exactly where I was expecting it to be. So I can go ahead and draw this whole entire branch.